Alright, in this video I'm going to go through how to add and subtract rational expressions. So we're going to add, subtract, and simplify some expressions with common denominators, and then we'll get into some where your denominators are different, and those ones are going to require a little bit more work. So I'm going to go through a good chunk of problems, starting with some of the easier ones. So the cases when you already have a common denominator. So in both of these expressions, so these are rational expressions, my denominator is 4x. If that's the case, it really is as easy as us just adding the top together and saying, hey, that's 15 plus 5, so that is really 20 over the 4x, and then simplifying that, you get 20 over 4x, that is 20 over 4 is 5, and then the x stays on the bottom. Alright, so something as easy as that. With this next one, I've got my x minus 8s here as my common denominator, so I'm going to just bring that down. And then bring down my numerator, 3x squared minus 6x. And what I want to do is just factor that numerator just to see in case we have a common factor. So I look at what I can take out of the numerator, which is a 3x. And if I divide a 3x out of each of these expressions, 3x squared divided by 3x is just x. Negative 6x divided by 3x is a negative 2. And then I've got my x minus 8 on my denominator. So that would be the entire problem. If I had a common factor, we would cross that off, but that is not the case. Moving on to this one, very similar type of problem. X plus 3 is already my common denominator. I can combine my numerators, and then I just want to factor again. So I think about what I can factor out of both of these expressions, which is a positive 5. If I divide a 5 out of each of those values or expressions, you're left with x plus 3. And then my denominator, which is x plus 3. So like I just said, like literally 30 seconds ago, if I have a common factor, I do want to cross that off, and I am left with an answer of just 5. Alright, some subtraction ones, same type of problem here. Common denominator is x minus 4. My numerator is x squared minus 16. That is factorable using the difference of squares. So it's going to factor into x plus 4 times x minus 4 all over my denominator, which is x minus 4. So again, I've got a common factor. That's going to cross off, and I'm left with x plus 4. So you can kind of catch on to the pattern. These problems are a lot easier if we already have a common denominator. The ones where you really want to be careful with your signs are like on this, where it's a subtraction problem, and I have multiple terms here. So what we still have again is the x plus 2 as a common denominator. I'm going to bring the 2x down. Now we're going to be really careful. It's a minus, and then in parentheses you want to put the expression 5x minus 4. And that parentheses is insanely important because the negative 1 that's in front of the parentheses is going to distribute. So I really have 2x and then minus 5x, and this is why the parentheses are important, is now it becomes a plus 4. And then my denominator is x plus 2. So simplifying the numerator, just combining some like terms, I get negative 3x plus 4 over x plus 2. And that's as far as we can go. So I don't want to try anything kind of weird and be like, oh, I'm going to take 4 divided by 2. That's not going to work since those are not factors. If I had like a 4 and a 2 on the outside, like something like this, now that 4 and that 2, now those are factors. Then you can do some cross-offs and simplifying, but that is definitely not the case if we end with something like this. Alright, and then part F, again, I've got common factors here of 4x times x minus 1, so it's a little bit larger of a denominator. But that doesn't change the fact that, again, on the numerator, I'm really just going to combine my like terms here. And we're going to end up, wow, I just wrote that wrong. Okay, we're going to end up with 8x on the top. And then my denominator is 4x times x minus 1. So this is one of those cases where we have a factor, and I just want to keep using that word, we have a factor of x here on the outside of the parentheses. And then I've also got the 8x over the 4x, so the 8 over the 4, which is going to make 2. And essentially, these x's will just cancel out. 8 over 4 is 2, so I'm left with 2 on the numerator, and then x minus 1 on the denominator. And I just want to bring up a point that if those values were reversed, suppose I had something like this, I want to bring up that, again, the 4 and the 8 are going to simplify, but in this case, the 4x over the 8x would really simplify to 1 over 2. and you'd still need that 1 on top, and in this case the 2 and the x minus 1 would be on the denominator, if that were the case where it was flip-flopped. So now the ones where there's just a little bit more work involved is we want to find a common denominator for each of these expressions. And it's going to work just like finding the common denominator of 5 and 6. Hopefully you would say 30. And now that I've got an x involved, the x needs to come down as well. So I've got a 30x, and I think about what I would need to multiply 5x by to get to 30x. So, and that works just like when we used to add and subtract fractions. Same thing, is you want to think about what you need to multiply this denominator by to get this denominator, which is 6. And whatever I do to the denominator, I have to do to the numerator. And then I'm going to do the same thing over here. What would I need to multiply this denominator by to get to this? And so I'm going to take that, so I'm going to take that 7 that I had up there, and that 7 would need to be multiplied by 5. Notice there's not an x included on either of those in the numerator, and that's because your denominator of your fraction already had the x. And we're going to see that that's going to be a little bit different in the next one. So 12 times 6 is 72, 7 times 5 is 35. I'm going to take that over 30x. And then that's going to end up, when I add these two together, I'm going to end up with 107 over 30x. All right, that would be it. Okay, so moving on to this next one then. So a little bit more of the common denominators. I know that between 3 and 4, I'm going to have to come up with 12. And then I want to look at the higher of my two powers on these. The fact that x squared is my higher power, we're going to just bring an x squared down. You do not have to multiply these two expressions together, because if you took 3x squared and multiplied by 4x, you would have 12x to the third. The whole problem would actually work out the same way. You would just be making a little bit more work on yourself. So I'm going to look at which of these has the higher power and make that the value in our common denominator. So it still goes back to before. What am I going to need to multiply the 8 by? So we think about, what would I need to multiply 3x squared by to get to 12x squared, and that's simply just a 4. And this is going to be different. I'm going to bring down my minus, I'm going to bring down my 5, and now I need to think about what would I need to multiply 4x by to get to 12x squared, and that's not just going to be 3. Because this was x and this is x squared, the question again is, what would I need to multiply this expression by to get to this? And you would need a 3x. So I'm going to end up with 32 minus 15x all over 12x squared. If we were able to actually go further than this, I would want you to kind of factor if we can. There's no whole number that goes into 32 or 15, so this is our final answer. Again, the x's will not cancel because the 32 doesn't have an x with it, so it's not a common factor, and this is where you would stop. Something like this. So now we've got a couple of denominators. There's pieces that are in common and there's parts that are different. So what I want to look at is all these different factors, or all these parts. I have the 5, and that is already in common with both. I have an x here. This x is different than this x, and the reason is this one's got the minus 2, which makes this whole expression a factor. This x is its own factor. So really my common denominator is going to need the 5, it's going to need the x, and it's going to need the x minus 2. So building the common denominator is, I think, the most challenging part of these. Now we just have to look at, again, just like before, what does this denominator need in order to look like this denominator? So I need to think about what my x minus 4 needs to multiply by. Again, what does this need to be multiplied by in order to get to this? And that would be the x minus 2. I bring down my minus, I bring down my 12, and I do that same thing where we think about what would this denominator need to look like this denominator, and all that it's missing is the x. So now it's a matter of just multiplying and simplifying. I'm going to multiply out that first set of parentheses here. That's going to give me x squared minus 2x minus 4x plus 8, and then bring down the minus, and then 12 times x is 12x. All over that denominator, 5x times x minus 2. So now I'm going to simplify this numerator. I have an x squared, and then I have negative 2x minus 4x, which is negative 6x, minus 12x, which is negative 18x, and then I have a plus 8. All of that over 5x times x minus 2. What we actually want to check is if this thing is factorable. Then you would want to see if, and that kind of goes back to the very first problems we did where we were like factoring and canceling stuff. But in this case, there's nothing that multiplies to positive 8 that adds up to negative 18. So this is your final answer. Again, you cannot just start crossing off x's because we don't have common factors of x. Something like this, again, this x is different than just this x. So you need to think about this like it's an entire expression. This is an entire expression. Your denominator is honestly just made up of both of those expressions. Nothing more than that. So, I mean, this problem is a little bit more basic in a sense that you've got one of these and you've got one of these, so my denominator has each. And then you have to think about what the x plus 4 would need to multiply by to get to this. And that's what 3 is going to be multiplied by. And that's going to be the x plus 6. Bring down the minus and be very careful. Put the 1 there. And again, we want to think about what would the x plus 6 need in order to multiply to become this denominator. And that would be the x plus 4. So now it's a matter of just simplifying. I'm going to distribute the 3x across. And then I'm distributing this negative 1 across. And that's where, again, the parentheses are important because I'm distributing the negative. I'm going to leave my denominator, since it's already in factored form, it doesn't really make sense to multiply the entire thing out. And what I'm left with is 3x minus x, which is 2x. And I have an 18 minus a 4, which is a positive 14, all over the x plus 4 and the x plus 6. And then my last step is to just factor my new numerator, which we have two even numbers, so both are divisible by 2. I can factor a 2 out, and I'd be left with 2 times x plus 7 on top, and then on my denominator, x plus 4 times x plus 6. Again, no common factors, so I can't just start crossing stuff off, and that is your answer. A couple more then. So with something like this denominator looks pretty ugly right now, so what I think we should probably do is factor it first. So I think about what multiplies to negative 24, that adds up to positive 5, and that's going to be positive 8 and negative 3. And then over here I've got a 3 and then an x minus 3. So as far as our common denominator goes, this fraction on the left already has an x plus 8 and an x minus 3. This one on the right already has the x minus 3. So this is a common factor between the two. So we don't have to put it in the denominator twice. My common denominator is going to just have the x plus 8 and the x minus 3. We do not have to write it twice because it was already in common with both expressions. What that means then is this 12 is all good to go. There is nothing that the fraction on the left actually needs in order to change to our new common denominator fraction. This one on the right, you can see that the x minus 3 is going to need an x plus 8. So that means my 3 needs to be multiplied by x plus 8. And we just carry on the problem like we did before. Be very careful with your algebra in order of operations that we don't add 12 and 3 and make it 15 and then distribute 15. We're doing order of operations, which says I should distribute that 3 across. And we get this. And then on my denominator, I'm left with x plus 8 times x minus 3. The next step is simplifying, combining like terms here. I've got a 3x on top plus a 36. And I'm left with x plus 8 times x minus 3. And then the last step is to factor my numerator. Again, I'm going to factor out a 3 from the numerator. And if I divide each of those terms by 3, I'm left with x plus 12. And on my denominator, I have x plus 8 times x minus 3. Again, no common factors, so I can't cancel anything out. The 3's don't cancel because this whole factor has x minus 3. I think this is the last one. Sweet. Okay, so with this one, again, we want to factor first, and there's a difference of squares involved. So my denominator is going to factor into x plus 2 times x minus 2, and over here I have a 15 over x minus 2. So, very similar to the last problem, the x minus 2 is already a factor of both expressions. So, when you make your common denominator, you can use x plus 2x minus 2. You do not have to put the x minus 2 in there twice. that means that the x plus 4 that's on the numerator is already good to go. The 15 comes down, and in parentheses, we need to figure out what this fraction on the right needs in order to look like this one, and that's the x plus 2. So my numerator is going to become x plus 4 minus 15x minus 30 all over, and then x plus 2x minus 2. And again, we want to do some combining of like terms here. I have an x minus a 15x, so that's negative 14x. A 4 minus a 30, that's going to give me a negative 26. And then the denominator is x plus 2 times x minus 2. And then lastly, out of both of these expressions, I can factor a 2 out. You can factor a 2 out. Since this first value is negative, I'm going to factor a negative 2 out. And if I do that, negative 14x divided by negative 2 is positive 7x. And then negative 26 divided by negative 2 is positive 13. And then my denominator is still the x plus 2x minus 2. All right, so that is all of it. Again, I think the second batch of problems is a little bit more work than the first ones that we did because we had to make that common denominator first. But that is it.